Hello, honors algebra students. Mr. Lawrence here, and some of you got some front loading yesterday with finding ways to solve quadratics, and we did so by factoring. Now, I've got a question for you. How can I solve a quadratic equation when factoring won't work? Well, we're not actually going to answer that question today, but we are going to highlight the discriminant. Wait, I said highlight it. Oh, I'm so sorry. Let's highlight the discriminant. There we go. The discriminant. Remember, the discriminant can tell you if something can be factored, right? It's actually way more powerful than that. That's important, but it can tell you. Remember, the discriminant is b squared minus 4ac. The discriminant can tell you lots of things. So let's find out what it can tell us. Hold on, I'm going to sneeze. Sorry about that. Hopefully I didn't blow out your eardrums. All right. If b squared minus 4ac equal to perfect square, we know it's factorable, right? We know that. Perfect square, we know it's factorable, right? And that's actually more important than that, more powerful than that. It's going to give us two rational solutions. Two rational solutions. They'll be real numbers, and they'll actually be rational if it's factorable. Okay? If b squared minus 4ac is just greater than 0, we're not going to be able to factor it, but that is going to tell us that there are going to be two real solutions, and those real solutions will they will be irrational. They will be irrational numbers. Okay? They'll involve the square root of 7, or maybe, the square root of 27, or something like that. Okay, so if b squared minus 4ac is a perfect square, the equation is the expression is factorable, and the equation will have two real solutions, and they'll both be rational numbers. Yeah, sorry, I lost an S there. If b squared minus 4ac is greater than 0, we're going to get two real solutions, all right? But they'll both be irrational. If b squared minus 4ac equals 0, well, again, it would be factorable. It would have to be. It would have to be factorable because 0 is a perfect square, so it would be factorable. But in this case, we're only going to get one real solution, and that real solution would be rational. It will be a rational solution. Okay? Now, if b squared minus 4ac is less than 0, that tells us that we will get, it's not factorable, of course, and we will get 0 real solutions. Okay, there will be some imaginary solutions, but we won't deal with those in this class. That'll be an Algebra 2 thing. I don't think you'll see it in geometry, but it's possible. All right, so I would definitely learn this, maybe flashcards, Quizlet, something like that. All right, so let's check it out. Let's check out problem number 1 here. Well, I've got to identify A, B, and C. So let's see here, A, B, C. Easy as 1, 8, 2. Okay, so b squared is going to be 8 squared minus 4 ac. And so I'm going to get 64 minus 8, which is going to be 56, okay, which is not a perfect square. So this cannot be factored, but it can be solved. You don't know how to solve it yet. We'll learn that soon. And both solutions will be irrational. We'll have two real solutions, and they will both be irrational. Yep. Okay. All right, let's check this one out. Number 2, got to do A, B, C. Easy as 21, 1, negative 10. Okay. If I do this one, I'm going to get 1 squared minus 4 times A times C. All right, well, 1 squared is 1. It's going to be plus because I'm going to add 2 negatives, multiply 2 negatives. I'm going to get 84 is going to be 840. That's going to be 841. Off the top of my head, I don't know if that's a perfect square, but let's check it out. Let's open up my graphing calculator. Here it comes now. I've got a feeling it's a perfect square. Yeah, I've got a feeling it's a perfect square. Let's do 841, and we'll raise it to the 1/2 power, because that's the same as taking the square root. And 29, there you go. It's a perfect square. So this is factorable, the expression. So it's factorable, and there are two real solutions. And both solutions will be rational. They'll both be rational numbers. Rational. Okay. Oops. All right, number 3. Some of them might recognize that as being prime, and it is prime. But let's check out b squared minus 4ac. So b squared would be, b would be 0, right? Minus 4ac. And so I'm going to get 0 minus 36, which equals negative 36, which means there are 0 real solutions. So this one can't be solved. Can't be solved because the discriminant ended up being less than 0. And finally, number 4, let's see, A, B, C. Easy as 5, 14, negative 25. And so, square 14 minus 4 times A times C. That's my negative there. All right, and so I'm going to get 196 plus, and let's see, 20 times 25, 500, right? 25 times 2 would be 50, so 20 would be 500. And so if I add those together, I'm going to get 696. I don't know if that's a perfect square, but I got a feeling it might be like 26. Let's check. 696, and we're going to raise it to the 1/2 power. Oh, it's not. It's not. It's close to 26, but not exactly. So this will have two solutions, but two real solutions, but they will be irrational numbers, okay? So you're going to check the discriminant. I'd like you to practice yourself here. I want you on these 4 problems to determine how many solutions and what type of solutions they are for each quadratic equation below. So I would like you to pause the video, use the discriminant, and see if you can determine how many solutions each of these have. Soon we'll be learning how to solve them. Okay? Here come my solutions. Make sure you've tried all 4. So for the first one, it won't move. There are 2 real solutions, and they'll both be irrational. The second one, there's 1 real solution, and it's a rational number. The third one is 0 real solutions, and the fourth one is 2 real solutions, and they are both rational. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.